Hello and welcome to this section of the MATLAB tutor. Here we're going to use the concepts that we've been developing with regard to vectors, and we're going to do some very basic statistical calculations with them, because a lot of times if you have raw data you'll store it in a vector, which is just a list of numbers. So it might be handy to be able to calculate a few key parameters. So for instance, I may be a teacher, and so I may have some students and I may be collecting grades. So let's say some of the grades in the class are 100, 91, 92, 85. One guy got a really bad grade of 40, or one lady got a bad grade of a 40. Then I have 1C, and then most people in the class doing pretty good, something like that. So these are all the grades in my class. Of course, keep in mind I may have 200 people in my class and have a much longer vector. So here's my grades vector. It's all compactly held together. Everything's in one nice unit that I'm calling grades. And I might like to know, okay, well, let's go ahead and figure out what is the mean of these students here. So their function for that in MATLAB is just mean, and you just pass the vector grades to it, and then it'll basically calculate the mean in the normal way. Add everything up, divide by the number of items there. So the mean for this class is 84.6. Perhaps I'm interested in calculating the median. So the function for that is median, and it'll go off and look at the middle value there. This is a good opportunity to also use another function that we learned in a previous lesson. If you use sort on the vector grades, then it'll order my vector from least to from smallest number to larger number. So if I order them like this, and I can look in them right in the middle here is a 91, and that's why the median is 91. That's the definition of what a median is. You order your list of numbers from smallest to largest, and the median is whatever is going to lie in the middle. Whereas the mean is more of a calculated value where you add everything up and divide by the number there. So let me clear the screen, get that clutter off, put our grades back up on the screen. Now, another thing we might be interested to figure out is the standard deviation, because a lot of times the mean is not that important. Well, it's important, but it's not a complete picture without knowing what the standard deviation is. So if we go and want to do the standard deviation, it's STD. That means standard deviation, and you pass it the vector grades that you've created, and then it calculates a standard deviation of 17.9. So when you look at the mean and the standard deviation together, that gives you a complete picture. If you were to plot this and fit it to a bell curve or a normal distribution, that would give you the complete picture. It's important to know that the mean of the student grades is about an 84.6, but it's also very important to know that the standard deviation is about 17. So that means that if you kind of look at it as a bell curve, then the distribution is really going to start to taper off when you get to around 17 or 18 points away from either side of the mean. Now, again, here's a good opportunity to use some of our previous stuff. I can make another vector called grades 2. So what I'll do is I'll modify this guy. So what I want to do is I want to start off with the grades that I originally had, but I want to add some other grades to it. Let's say I had some transfer students come in at the last minute, so I had my original grades, and now I want to add in maybe like 4 or 5 other grades. And let's say these other grades were really, really poor. So let's say they did really bad. Here, this guy got a 24, this person got 51, this person got a 47, this person got a 60, that's relatively good, and this person just did terrible with 19. He just didn't study at all for the test. So what I'm doing here is I'm creating another vector, and I'm going to have the values of the original vector that I have up here, but I'm going to kind of append at the end these additional grades. And so you can see that that's what I have here. This vector contains the original grades, and then over here I start to add these other guys here. So whenever I go back and try to calculate the mean of this, you would expect it to shift lower. So let me put the mean of grades 2, of course, is now a 68 as compared to the 84 that it was, and the standard deviation should change a lot too. Grades 2, the standard deviation is much wider because I have these outliers over here that's basically, kind of tore up the class performance. So the mean shifts lower, and the bell curve, so to speak, gets wider. So the shape of it, if you fit it to a normal distribution, to a bell curve, so to speak, gets fatter because the average distance, so to speak, away from the mean is a whopping 28 points now. And if you had a class of overachievers, with really high grades, grades 3, if you had a class of very high achievers, then you might have 100, 100, 100. One guy got a 97, one guy got a 95, one guy got a 90, one guy got a 96. And if you calculate the mean of these guys, of course the mean is going to be very high, and the standard deviation is going to be really tight. You see how the standard deviation is only 3.6? It's because these grades are so tightly compacted. So the mean is 96, and this standard deviation tells you that the spread of the students is not that great. It means they're all doing really well. And finally, I'll close out by saying the standard deviation is super important in statistics. Sometimes you might want to calculate the variance. So let's calculate the variance of grades 3. And you do that with a VAR command. And the variance is 13. And for those of you who have taken statistics, you'll know that the variance is simply the standard deviation squared. So if you actually take this 3.67, I'll just do it 3.6710 and square it, you're going to get the variance there. So MATLAB has built-in commands for mean, standard deviation, variance, and median. So definitely use those guys. A lot of times you'll import data, you want to do quick analysis on it. Those are the basics. Those are the things that are going to get you by with most of what you're going to do in everyday situations. And then of course, when you get into more advanced statistics, MATLAB has a whole additional suite of other tools that you can use to tackle your problems.